All right, today we're going to talk about postulates and the diagrams that go with them. And as we recall, a postulate is a rule that we don't have to prove that everybody already agrees on. So the first one we're going to look at the 2-point postulate. Through any 2 points, there exists exactly one line. And here we got points A, and we got points B, and exactly one line connects the 2 points. Then the line-point postulate. A line contains at least 2 points. So here we have a line, and we know somewhere on the line we have at least 2 points. We'll call them C and D. So through any two points, we have a line. Through any line, we have to have at least 2 points. The line intersection postulate is exactly what it sounds like. If 2 lines intersect, their intersection is exactly 1 point. Then the last one on this page, the 3-point postulate. Through any 3 non-collinear points, there exists exactly 1 plane. And as we recall, these are all definitions that we learned earlier. Let's keep going since there's more to do. All right, plane point postulate. A plane contains at least 3 non-collinear points. So let's put 3 points, and let's call them X, Y, Z. They have to be in there somewhere because it's a plane. And I forgot to draw my 2 points. So if we have 2 points, I and J, and they're on plane R, then the line that connects them, line L, also is on plane R. Our plane intersection postulate. So if we have 2 planes intersect, so we got planes S and T, and they intersect, and their intersection is right here on line M. Their intersection is a line. So line M is the intersection of plane S and T. So it's actually very simple. It's all part of the definitions that we would have learned earlier in the course. So let's look at the diagram and then state our postulate that we just went over. If 2 lines cross, then they cross at exactly 1 point. That is the line intersection postulate. Skip down to the next one. State the postulate illustrated by the diagram. If 2 planes intersect, then they intersect. Their intersection is a line. That one's right here. It is the plane intersection postulate. Why don't you pause the video, attempt the next 2 on your own, and then restart it, and we'll see how you did. All right, now that you attempted it, let's see what we got. So if we have a line, then we have at least 2 points. That's the line point postulate. And then here we have, if we got 3 points, then we have a plane that all those points are on. That is our 3-point postulate. Let's keep going. Let's take a look at what we have. Right, 2 examples of the plane point postulate and the plane line postulate. Well, the plane point postulate, we've got plane P, right, because here this is plane Q, and then here we have plane P. So plane P contains points A, B, and C. So the plane line postulate. Well, so points A and B lie on plane P. So line N, which is over here what we named AB, is on plane P. Why don't you pause again, attempt this page, both this problem and this problem down here. Pause it, attempt them, and then restart, and we will see how you did. Okay, welcome back. Let's see how you did. In the diagram, which postulate allows you to say that the intersection of plane P and plane Q is a line? We look back what we did a little bit earlier. The plane intersection postulate. Use the diagram to write an example of each postulate. The 2-line postulate. The 2-point postulate. 2-point postulate. Line N passes through points A and B. Okay. The line point postulate. Line N contains points A and B. And the line intersection postulate. Line N and line M intersect at point A. So, good job. So let's do some sketching, which is always fun. Sketch a diagram so the line TV, so let's draw TV, and it's a line, so we're putting an arrow on each end. Intersecting PQ, segment, so these are endpoints, at point W, so that's point W in the middle, so that TW is congruent to WV. So we draw the line, the intersecting segment, all the relevant points, and then we put our little dashes to show congruence. And we're done with that one. All right, so sketch showing ray VX intersecting line UW. So let's draw a line UW. U and W at point V. We've got to have an X out here so that VX, ray VX, is perpendicular to the line. So we'll draw our little box out there, which shows that it's perpendicular. And we're done, and we can move on. All right, here we're going to use the diagram. And which of the following statements can we not assume from the diagram? Points AD and E. AD and E are coplanar. Here's E, here's D, and here's A. Well, I know from the three-point postulate that any three non-collinear points are on the same plane. And then we want to evaluate AB equals BF, which is right here. Nothing to indicate that those are congruents or what the lengths are. So we cannot assume. We cannot assume. This is true because of the three-point postulate. All right, we're going to use the same diagram, so let me clean it up a little bit. See, which of the following statements can we not assume? A, B, and F are collinear. A, B, F. Well, they're all on the same line, so they are okay. Line AB. Actually, let's do that one in red or pink. Line AB right here is perpendicular to plane S. Well, here we got a box to plane S, so we know that one's true. Points E, B, and D. E, B, and D are collinear. No line connects it. We can't assume that a line would connect them. We don't have that information, so we cannot assume it. So let's do line CD. We'll do it blue. And we get line CD right here. And is that perpendicular to plane T? The answer is 3 words. I don't know. We do not have a perpendicular marking on it, so we cannot assume that. Okay, line AF, which is our pink one, intersects line BC, which we'll do in light green right here, at point B. That is true. So we cannot assume facts not in evidence. We can't just look at something and say, yeah, that looks like it's true. We need proof. We need numbers. We need the box that shows it's a right angle. We need the tick marks to tell us that something is congruent. All right, so here, a line is perpendicular to a plane if and only if the line intersects a plane in a point and is perpendicular to every line on the plane that intersects it at that point. So here line T is perpendicular to line P. Here we're perpendicular to line Q. So that's going to tell us that we are perpendicular to plane A. Because every single line that goes through here on this plane, we have to be perpendicular to. All right. If it is given that segment PW and segment QW are congruent, how can we indicate this in the diagram? Well, here we got tick marks showing that TW is congruent to WV. So if I put one tick mark in there, that means that TW is congruent to PW, and that's not the information we were given. So we got to put 2 tick marks to show that PW is congruent to WQ, but not necessarily congruent to TW and to segment VW. So we're going to draw it just like that. All right, then we're going to name a pair of supplementary angles in the diagram. So any linear pair is supplementary. So we're just going to pick one and we're going to go angle TWP and angle PWV are supplementary because they're a linear pair. We could have done PWV and VWQ would have been true. VWQ and QWT, QWT and TWP are all valid answers because any linear pair is supplementary. And with that, we are done.